thing out. You're going to see things that have x's, and there's going to be some exponents with those x's. Probably, you might have seen this before. Maybe Mr. Staublin wrote, you remember seeing that? Did you ever see that? That's like a lot of subscripts and superscripts. That's what a polynomial is going to look like, except these a sub n's, that's a subscript, are going to be numbers, and these n's, n minus 1. The reason why I'm writing that is typically we put the highest degree term first, and then we write it in descending order. Okay? Do you kind of, sort of, does this sound maybe familiar to you? A little bit. Okay, so one thing that you need to know in order for it to be a polynomial function is that the exponents must be positive numbers and the exponents must be integers. Okay, so 0, 1, 2, 3. We have another name for things that have different exponents. And also what you want to be aware of is we study something else that looks something like this. Ooh. It's never this quiet in here. What's that? Is that polynomial? What's the difference between this and what you see there? Something about x, yeah. X is in the exponent. This is not a polynomial. This is exponential, and that is something we study, but it's important to note that exponential functions have a variable in the exponent, whereas polynomials, the x is the base of the exponents. Okay, so now that I just told you that, here's your job. Tell whether the following is a polynomial. If so, state the degree and leading coefficient. What do you think about letter A?
No.
Why not? Okay, well, the very first thing that we said is exponents must be positive. Now this is the thing. It's actually going to turn out to be a division sign, but it's not a polynomial. All right, how about B? Yep. Can we have a fraction for the coefficient? Yes, you can have a fraction from the coefficient. The deal is you just can't have a fraction exponent. See, there's a 5. That would be a 1, right? This is degree 0. So this is a yes. Standard form, it's already written in standard form. So if it's not, then you just list the highest degree and then you list them in descending order. But the degree of the polynomial is just the degree of the highest degree term. So looking at that term there, 2x to the 5th, what is the degree of that x? What's the exponent? 5, so we would call this a degree 5 polynomial. And then the leading coefficient is just the number that is in front of that first term. So the leading coefficient would just be that 2. Okay, let's move to C. What do you think?
No.
Yeah? Do you think C is a polynomial?
No.
Well, but wait, what if I took the cubed root of 27x cubed and the cubed root of 8x to the 6th?
How do you do this, Paul?
Can you do that?
Yes.
Can you do that if there's a plus there? No, you can't separate radicals that way. Let's say it was just this. Let's say it was just the cubed root of 27x to the 3rd. We could do that. The cubed root of 27 is 3, and the cubed root of x cubed is, and that would be a polynomial. But because there's this plus here, you can't do like cubed root plus cubed root. They don't work that way. The only way that's like a killing cat thing. It's like a cringy math mistake. You can do separate if it's multiplication but not addition. And what that means is I would have these things with a 3 and a 6, but that cubed root around it makes it not a whole number exponent. So this would be a no. Okay, next. We're going to touch on linear because we did this already in our chapter P. I'm not going to spend a lot of time on it because you guys were rock stars with that. You already know how to do this. Yeah. I'm just making the connection that a linear function, what word is in linear?
Line.
Line. You recognize f of x equals mx plus b, or y equals mx plus b. Yep, slope-intercept form. Does anyone remember the other way I told you could write these from chapter P? Mm-mm. Come on, somebody does. Mm-mm. I'm just going to wait. The point slope form, yeah. So, or you could write it like this. Y minus y1 equals m times x minus x1. Okay, so just a reminder on how we write a linear function then. So we need either the slope and the y-intercept, or we need the slope and a point. So in this first example, if I write it like this is just function notation because this is the x coordinate and that's the y coordinate. So f of negative 4, 6 is the same as negative 4 is the x coordinate and the y coordinate is 6. This would be negative 1, 2. I have 2 points, but what do I not have?
Slope.
The slope. Would you please take those 2 points and would you find the slope for me? Negative 4 over 3. Is that sounding like what you got as well? Mm-hmm. Okay, so as far as writing our lines today, I'm going to go ahead and put this in point slope form. What I will tell you is if you have 2 points, there's 2 possible point slope forms. Okay, either is acceptable. If you would distribute your point slope form, we would all get the same slope intercept form though. So I take my negative 4/3. I'm going to just go ahead and take that first point. I write y minus 6 equals negative 4/3, and this would be x plus 4. And I'm going to assume that if I asked you to, you could distribute, because we're all in precalculus. I think we could do that. Okay, now, because we complained about this a lot, some of us complained about this a lot, I thought we would want to review linear regression. Remember we did that last chapter? Okay, so between you and the person next to you, would you get one book out and turn to page 164? Just one between the two of you. We'll share, and that's the only reason we're using your book today. Okay, so I put some reminders here. We're on page 164. We're going to look at question 49. I picked some data that's not a ton. Just a reminder how to input your points. That's the very first thing we're going to do. question number 49. So what we're looking at is a group of male children, their age in months, and their weight in pounds. So what we're going to just do is review how we make a scatter plot, how we run a linear regression. Grab a calculator if you need to. Trade me. I'll give you a second.
Let me just write this down. 18, 20, 24, 26, 27, 29, 34, 39.
Okay, we're all start working. We're gonna go to stats first, edit, and we're gonna put. Now, hold on a second. Do some of you not have L1 and L2 showing up?
No.
God, it's blurry. Who doesn't have L1 and L2 showing up?
32,
Really?
32,
Wait, I got it.
You got it? Okay. Because I can show you how to get there.
39.
All right, we're gonna put in our points.
Like graph or something.
There's a reminder on there. There's a reminder.
Is there a reminder? Quad reg.
Wait, is it quad reg or lin reg?
It says both.
Oh.
It says or quad reg.
Well, did you look at the scatter plot? Did you follow what it says for the
Both.
go number 2. Look at number 2 on the notes. 29, 34,
Oh, you got that.
42.
And go to stat. Oh. Not the wheel. Put in four.
Okay. Are we ready?
Yep.
Okay. How do we do the graph? I go stat plot, which is second y equals, and I turn one on. It says turn. I should have put the turn on around the whole thing. Okay. And then after I do that, I hit zoom 9. Does that look linear or quadratic to you?
When
It looks linear to me, okay? All right, now run a regression. How do we do that? It says right here. We're gonna go stat over to calc. Today, because we thought they looked like a line, we're gonna do lin reg. And we get that. Are we good with that? Okay, now let's write this in terms of our data. What was in list 1? The age in months, right?
yeah.
And list 2 was the weight. So what I'm going to do instead of y equals is I'm going to write the weight of the child equals, I'll call this 0.825 times their age in months. So we can use A or M for month. I'll do months. Plus 7.818. Are you understanding where that comes from? Because now what I could do is I could use this to predict other weights. Like let's say if I said, hey, would you predict the weight of a 44-month-old child? Where would you put 44 months in? For M, and then it would tell you the pounds. Okay. Let's talk about this. R. I think all of us should have R showing up, right? Okay. So we would just call this, if I'm looking at my, R is 0.945. That's pretty good. The closer it is to 1, the better. And I don't know if you've seen this on an PSAT before. They might ask a question where it just says describe the strength and the direction. The strength would be, that's pretty strong. It's going up, right? So we call it positive linear correlation. And all that means is there is a strong relationship that when the months goes up, the weight also goes up. That's what that means. Okay. As opposed to if you saw like this, those kinds of dots, what would you call that, do you think? Is that linear?
No.
No, that would be more of like a quadratic relationship. Okay, that's all I wanted to do. Did you